Hello. This lecture is again about 3D printing. Now, processes and materials in 3D printing. What are the learning outcomes? First of all, basic knowledge about different 3D printing approaches. What are the main material types used in 3D printing? So, different materials need different approaches. And we all know that in our world, we are using so many different materials. However, different approaches have specific limitations. Engineers, technicians, and designers have to know the capabilities offered by different technologies to have good results in their work. So when we are selecting production method for our design, there might be different considerations. First, material. If we look around in our environment, we can see so many different materials. They can be metals, plastics, very many different materials. And the properties can be very different as well. So, because properties are very different, it also means that different technologies might be used for this manufacturing process. Now, next consideration could be accuracy, because some parts need to be really accurate. But with higher accuracy, we also might introduce higher price. So not always we need higher accuracy. Sometimes we don't need it. We want to just produce something fast and cheap. So surface quality is another issue. In some cases, surface quality has to be really high. But in some cases, in case of invisible surfaces, maybe it's not an issue at all. Of course, logically, if we think to get better surface quality, we need to do something extra. So it means that the price is higher, probably. There might be some requirements for color of the part. Maybe there are some parts that have to be special color. Maybe in the product some parts have to be yellow, some red, some black, for example. Then coating is another issue. Coating can be applied or something that's put on top surface of the part to give some kind of properties to the surface, only to this surface. But from inside, the material is different. But it could be also this way, that we want a part to be without coating and with the same material with the specified color and so on. Then there are some specific properties that could be required from this part to function properly in the product. For example, mechanical properties like strength, hardness, surface hardness, so the wear properties are better, so it will function longer. Then there might be electrical properties. The part could be conducting electricity, or the opposite. Maybe we don't want that at all. There could be optical properties that are required from this part. Maybe the part has to be as transparent as possible. Maybe there are durability issues. For example, maybe it has to work in some high temperature or very low temperature. or maybe it has to work all the time in room temperature near 25 degrees. So the requirements for these technologies can be very different. Some parts need to work in ultraviolet light, for example. But some materials, if they're constantly exposed to ultraviolet light, they will degrade. The properties will worsen, and the color, for example, might change too much. So another issue is availability of the technology. Maybe there is some kind of technology that is invented somewhere, but if it's not available for you to use, then it's another limiting issue. There might be price issues. Maybe the selection of the production method depends on the price. If it's too high, then it's not suitable. And of course, time is also always serious limitation. Maybe some technologies take too much time to be used in real production environment. For example, if you need to produce just one part, and the printing of the part takes 10 hours. If you need only one part, then it's not a problem. You can print it. But if you need 10,000 of these parts, then you cannot use this technology that easily anymore. Now, there are several material groups encountered in art, engineering, and medicine, and other areas. So, large group is metals, and metals have very specific properties. Metals are very widespread class of materials. Then we have plastics. Plastics are also nowadays so widespread, so it's even said that in the oceans we have more plastics than fish. So it shows that plastics are very widespread, but we should also consider carefully what are the materials when we're designing our products. Now, ceramics. Ceramical materials are used in many areas. They have specific properties. Usually ceramic materials are brittle and very hard. So again, totally different properties when we compare them with, for example, with plastics. Now there might be biomaterials, then there are some food materials. For example, we might want to create something, some candy. We might print candy. And the very advanced class of materials is composites, like combination of different material types. It means that in one product we can combine strength of one material with the flexibility of something else, some other material, or some material that gives some specific properties. The manufacturing approach is different in most of these classes. So nowadays we don't have a universal machine that can produce prototypes or models from all of these classes. So selection of technology is quite critical. Plastics can be made of sheets with constant thickness, or they can be designed this way that the thickness of materials is changing all the time, or in different areas of the part. Then there might be thermoplastic materials used, or thermoset materials. It's a little bit different material class, then maybe it's required that we're using specific grade of materials. For example, food industry, in food industry, very limited number of materials can be used because some materials are not allowed because they, if they are in food, they are not very healthy for the people who are eating this food. So there might be different considerations. If we're talking about metals again, then we might create the part from sheet material, or we can use a material that has different thicknesses in different areas of the part. And in case of metals, we also have very many different grades. Some different grades of aluminum, some of the materials are soft, some of them are hard, and so on. In case of titanium, for example, some titanium grades are used in aerospace. They are lightweight and strong. Some materials or grades are used in implants in human body. There is a huge number of different steel grades, starting from normal construction steel, then tool steels, and different stainless steel grades. Now, when we're talking about composites, then there might be different composites that are needed in our engineering part. Fiber reinforced plastics, or maybe metal ceramic composites that are totally different from each other. Then there are ceramics. In some parts we need elastomers, which is basically rubber-like material that can deform a lot. It's in some cases very soft, in some cases harder. And in some applications, we need also edible materials that we can actually eat. Like on this picture on the slide, we can see a candy made of or printed using chocolate. There are special food printers available on the market. You can actually print chocolate candies or different material candies. And these machines are different than those that are used for producing plastics, for example. So on this slide, you can see the classification of 3D printing methods based on material form, the principle, and the technology. So we can classify material, or we can classify the technology by the raw material form. There are four categories, like liquid. Is this material in raw form liquid? Is it in filament form, like plastic wire, or is it powder? And the raw material can be also in sheet format. Now, depending on the principle, we can divide processes in 5 categories. First, polymerization. When we're using plastics, we can, and these thermoset resins, we can use polymerization technologies like watt polymerization and material jetting, where the material itself is in liquid state at the beginning of the process, and it is solidified using ultraviolet light, for example, or combination of temperature and ultraviolet light, and maybe something else as well. So filament-based technologies are using this molten approach where, for example, fused deposition modeling includes melting plastic filament and depositing this into, or extruding this into the final form, so it solidifies and creates the cross section of the part. So we can also use powders, and we can melt the powders, and when it cools down then it forms the solid object. Or we can use binding agents or glues to glue together powder particles to form the part. Or we can actually use also sheet material, and we can bond different cross sections of different sheets to form the part. It's called sheet lamination. So there are very different approaches, and these approaches have different trademarks and different companies who are producing the machines. Some of these approaches, they're like open source, or can be used by different producers. Some of them are very closed, so only few manufacturers are there on the market. However, to sum up this lecture, I would emphasize that different materials have different specific requirements for the manufacturing technology, and on the market or in the world, many manufacturing approaches are available, and actually several technologies can make quite similar products. However, details are different. Thank you for your attention.